Assalamualaikum and good morning all. We will start our tutorial today with question number 1. So please volunteer who will be answering question number 1.
Doctor, I can present.
Yes, thank you.
Okay. So can you see my screen?
Yeah.
Okay, so basically problem 1 is given a dice with 6 faces from 1 to 6, find the probability of getting 5. So we create the condition, the indicator random variable where 1 when 5 does occur and 0 when 5 does not occur. So for the second part is what's the probability of getting number 5 when it's thrown. So we use 1 divided by 6 because there's only 6 choices. So after that we do this, what is the expectation of getting number 5 in one throw? So we use the formula. So I then bracket 5, 1 times the probability 5 times a plus 0 times the probability of not getting 5. So it's 1 over 6, the same thing. So what is the expected value for getting number 5 in n number of throws? So basically you throw n number of times. So you basically add in an n here. So its answer is n power of 6. So that's all. Thank you.
N divided by 6, right?
Yeah.
The answer?
Yep.
Okay. Any questions or comment from Okay. Would you like to present problem number 2?
Okay also.
Okay.
Okay, so for number 2, the hiring problem is basically from slide, right? So here the pseudocode is hire assistant n. So we set the best to 0, and for I equals to 1 to n is basically looping. So interview candidate I. So if the candidate I is better than candidate best, then we will replace the candidate best with I, then we will hire candidate I. So we will continue to loop until we find the best candidate. So for the number 2, discuss step-by-step approach on how to find estimated cost. So we basically set again the indicator random variable. 1 for the candidate is hired and 0 for the candidate is not hired. So this is the EX formula to calculate expected. So the probability of I candidate to be hired is 1 over I.
Okay. So it's exactly the same. Alright, thank you so much. I need to recheck about the incompliancy of lemma 0 for this case, because I think to comply with lemma 0, we can the sample size should be the same as the probability. So now so means, right, the indicator random variable and the probability must be the same, but I feel that this hiring also comply with lemma 0. I will double check on this and let you know in the next lecture. Okay. Alright. Who would like to present part 2, question number 1? Any other volunteer? Or Zimping, do you want to volunteer?
Okay, Toto, let me open the file first.
Okay.
My computer is lagging.
Okay, it's okay.
Toto, can you see my screen?
Yes.
So I need to present question part 2, question 1.
Yes.
Write the circle of the iterative version of randomized select. I compare with the original code first. Because I just added from your code. Okay. Oh, wrong file. Never mind, I just explain from here. For randomized select, while true, if P equals to R, the P and R is here. The P is the first value and the R is the last value. We return AP, the first value, because we have out there the R or the P to the same value as the other. That means only one element left, so we just return AP. For Q equals to randomized partition APR. The randomized partition is, I forget the code already.
It's okay. I think you can open the code and compare.
It's quite similar to the sorting the quick sort. We will get the pivot of the if the index of the randomly chosen pivot.
So this is your answer, is it?
Let me explain it.
Okay, just show the differences because in this course we have known that any problem it can be solved using iterative approach or recursive approach. So we can convert. The only difference is when we analyze the time complexity, the timing is different between these two approaches?
Okay.
I
The
think
different
go down. Oh,
which facility
yes, that one.
are this? I have added a while through loop, and for the the recursive part, I change it to change the value of r. The r is here, the q minus 1 is r, so I just change it. And the else part, here, the p part now we update to q plus 1 as here. And the I part, we update to I equals I minus k. Then I add a while loop. While true, we just loop it until we have p equivalent to r or I equivalent to k. That's similar to the pseudocode in the PowerPoint slide.
Okay. All right. Is it in our collaborative environment?
Not sure.
Not sure. Our
Doctor,
I don't
the collab environment got problem. When I try to paste answers, cannot.
Oh, really?
Yeah, a bit
I
of
see.
like error or something.
Let me try. I try to paste the my pseudocode. Okay, I think now it's okay. Can you see? Can paste?
Let me try.
Okay.
Still can't.
Oh, you cannot? Oh, are you able to write something?
No,
Right now
cannot
can.
write. I can write stuff, but I cannot paste.
Oh,
And
you
it's
cannot
like
paste.
at the left side. The thing keeps starting at the left side. I cannot edit.
Oh, really? Okay. Has this happened before?
No, first time.
First time. No, I didn't do any different.
So maybe my page got problem.
Maybe something with the setting. So, any question about this? About converting recursion to iteration? What is your preference? Iterative approach or recursive approach?
Iterative.
Iterative. Why?
It's easier to understand. Recursion sometimes can confuse.
Yeah, because it call itself, it will divide first, then it will combine later. As we get, I myself got confused with recursion. It takes a while to understand the concept. But sometimes the recursive function can have better time complexity, right? Alright, let's take a look at the next question. Okay, any volunteer? I think about our previous lecture, it might go quite fast because we only have 1.5 hour. Okay, so do you have any problem or the things that you don't understand that you want to ask? Or it's okay?
Doctor, when is the time for midterm? Is it next week or week 8?
Alright, so for the midterm, it's supposed to be at week 8 and supposed to be on Friday 2:30. But when I chit chat with you previously, I noticed that some of you got class at 2:30. So we try to decide to make it during the lecture hour. But in lecture 8, if we want to rush into 1 hour, right, I don't think we can deliver the content well. So we have decided to do during lecture hour, not in week 8 but in week 9.
Right.
Because in week 9 is greedy algorithm. So that greedy algorithm is quite the lecture is quite short. So we can finish that within 1 hour. So is it okay if we postpone it 1 week?
Sure, no problem.
Postponing is okay, right?
Yeah.
Okay, Kisha is asking what is lemma 0, 1, 2? I mean the condition of each lemma. Lemma is like the mathematical proving, okay? That just like when we try to prove our big O theorem whether is correct or not. Okay, that is all. And for lemma 0, it's just a proving saying that okay, we have the sample size. Okay, sample size, for instance, for the flipping coin, our sample size is H and also T. And lemma 0 stated that the sample size is equivalent to the probability. So sorry, the expectation is equivalent. Sorry, let me open my slide. It's just a proving that okay, can you see my screen? Can?
Yes.
Okay. So lemma 0 is just proving that the expectation of getting the event A is equivalent to the probability of getting A. So if you want to ignore, we can ignore the lemma because it's just a mathematical proving. So we can just use this. We can include this in for step 3. That's why I feel that after thinking through, right, I feel that even for step 3, right, it is comply with lemma 0. But I have to reconfirm this. I have to reconfirm this. So for lemma 1, right, if you look at our reference book, right, is lemma 1 is this. They are just saying that okay, for higher assistant, this is the worst case, this is best case, and this is the average case. And what we try to do in here, right, is just to prove that this is true. That's all, Kishore.
Thank you, doctor.
So for examination, you can just follow the step 1, 2, 3, and 4. Then you will get the answer. Okay, shall we proceed to the next question? Okay, discuss step-by-step approach on how you would find the estimate cost of hiring a candidate. Show your working through indicator. Oh, sorry. Okay, this one. Suppose we use randomized select to select the minimum element of the array. Describe the sequence of partitions that result in the worst performance of randomized. So this answer is correct. Anybody would like to explain why is it this? Okay, I made some illustration for this question. So for randomized select, the random generator will select the pivot. Okay, so the pivot will be selected randomly. So the worst case that could happen if the random generator select 9, because right now, remember randomized select at one point, I think at step 3, we will do the quick sort, so that this pivot will be will have the left side smaller than the pivot, and then the right side smaller than the pivot. But when the random generator the worst case could happen if the random generator select 9 and we could not do the partition. So when we try to do the quick sort of this, right, in the end the pivot is already here. So the rest, right, remember when we want to do the select, then we can choose whether we want to do to the right or to the left. So because of this, right, we cannot proceed because I is always not equivalent to because if it's we got in the middle here, right, then we can exclude the searching. Okay, the difference between randomized, although randomized use quick sort, randomized is to find something, quick sort is to sort something. So for quick sort, of course, we will need to sort from the left and right, and when we want to do the searching, right, we can do the exclusion. So if the pivot randomly select is 9, right, then when we want to do the searching, we have to search the entire thing. So this will be the new array. So the worst thing happen, right? Okay, so just like quick sort, once the pivot is once we pick one pivot and then we do the quick sort, then this particular, we can say that the X pivot, right, is already at the right place. So we won't be considering this. Right now, we have to send all this to the randomized select, the recursion call. Okay, and then when we send this, right, suddenly the random generator select 8. Between all this, of course this one is already at the right place, and then this one they got it 8. So when we got it 8, right, then again we have to consider all this. Okay, to find, let's say we want to find median, because randomized select we can find median, can find the minimum or the maximum. Okay, so that's why the worst case performance happen when the random generator will select firstly they select 9, then they select 8, 7, 6, 5, 4, 3, 2, and lastly, they select 0. But it doesn't mean that this whole thing will need to be done, because when we do the randomized select, maybe we want to find the maximum number. So let's say this one so let's say this is the maximum number, then we could find it. So but right now we just say that they just want us to describe the worst case. They don't tell us what is what the thing that we are trying to find. Okay, so is it clear? So can one of you explain about question number 3, please? Ahmad Haris, you want to try? Kishore? So the question is how quicksort can be made to run in O n log n time in worst case, assuming all elements are distinct.
May I try?
Yeah, okay.
I'm not sure my answer correct or not because I guessed it.
Okay.
Yeah, this one. So my idea is just randomly pick the pivot point for the quicksort to reduce the chances to get extremely small or large pivot point value. So even the worst case means that maybe the array is arranging like maybe it's like already sorted. Then maybe the pivot point, if we choose the largest or we choose the smallest, that means the pivot point is not good because we cannot make too much of the separations between the middle point. We should choose the value that in between that, but yeah, unfortunately we can't do that, right? Then we need to like just randomly picking, then it can reduce the chances to get the extremely small or large pivot point. So although there is a possibility also getting that point, but it can already fulfill or already avoid many worst case can be happen. Yeah.
Okay.
Is it correct, Doctor? No, sir.
Yeah. Quicksort can be run in the worst case, assuming all elements are distinct. Yeah, like what you're saying, we try to avoid picking the smallest or the largest. Okay, and then one good way to avoid is to make sure that we pick the median, because let's say when we pick the median, right, our left array and our right sub array are evenly. So when they are even, right, for quicksort they want to do the sorting, so they will finish at the same time. Let's say we have input of 9, okay, and then our pivot it should be, okay, let's say 1 2 3 4 5 6 7 8 9. Then our pivot if it's median, then what will be the number?
I see. So maybe the Google Docs answer is more accurate. The question 3, choosing median as the pivot.
Hold on, yeah. Can you display?
Doctor, do we need to calculate the median?
Alright, in order for us to calculate, yeah, we can calculate the median for us to do. Let's say we want to find, we can calculate the median. So the best way, right? I think we have discussed this before, maybe not in this group. If we want to make sure that it's always at the best case for quicksort, right? When we choose our pivot, we try to make it median. So this to make sure that the left subarray and the right subarray the same. So just now I was explaining, let's say we have input of 9, okay, and then so our array, the array element is 10, 20, 30, 50, 60, 70, 80, and then 90, okay, but it's unsorted. So the best median that we can, the best pivot that we can select is 50, because after when we select 50, right, and then when we run our first quicksort, and then when we run our first iteration of quicksort after the J ends, then the 50 will be right in the middle. So we have the left subarray and the right subarray. Then
So
this left and right will complete at the same time. But let's say our pivot, right, because just now more you were saying that we can pick not extremely small or not extremely big. So we might be taking 30. So when we let's say we pick 30 as the pivot, right, then when we first round do the counting sort, right, our left element only have 2 element, and our right subarray 1, 2, 3, 4, 5, 6 have 6 element. So for sure, right, this quicksort will be run in average case, because even the left side already finished sorting, right, they need to wait. It will have like unbalanced tree. It will need to wait for the right side to do the rest. Do you understand, or do you want me to draw?
I understand the analogy, but in order to find the median, is it we need a particular algorithm that after we find the median, then we return the index for that array so that we can choose directly for the pivot point for that return index of the median?
Okay, good question, Moy. So right now in quicksort, there's no algorithm to calculate the median. So in order to choose the pivot, instead of we do like random quicksort, right? We just put the function random, and then all our array element. What we can do is we can try to get the median and try to search. So we plus all of the element, we try to get the median, and then after that maybe we can do some additional algorithm to make sure that we will get the median for that array. So let's say just now, understand?
Maybe a linear search is required to actually find the median now.
If linear search, yeah, probably. Okay, there are a lot of way. Linear search is one of the ways. So maybe you can come up with your own algorithm to the best way to find the median. Then once we find the median, then only it is still worth it, because one of the group, your senior group, right, they during their group project, oh no, it's the lab viva, because lab viva last year got 2 lab viva. They came up with the algorithm to calculate the median for quicksort. So that when they run it, right, that will is still worth it, which can make the because it's able to avoid the quicksort having time in worst case.
I understand. So, Doctor, my answer also correct, but no, it's not the best answer. I mean, by randomly picking, there's a possibility to still pick the small or large pivot point. But if we pick median, that means through the series of algorithm, we can just like pick median to make sure the algorithm is run in the best case or average case.
Yes.
Right.
Yeah. So if we pick the median, right, then our equation will be Tn minus divided by 2.
So
Okay,
by picking median, it is related to the random algorithm?
Okay. All right. Later, I will re-explain about the random random algorithm. You mean random select or random algorithm?
Some similar like random select for median.
Okay. Let's say if we use random, right, we select the pivot randomly, right? It is not necessarily that random algorithm will select median. So it cannot run the best case because random, right, is good for us to get the average case of things. So if we pick, if you able to develop a new algorithm that can pick the median for first the subarray and then first the whole array and then the subarray, right, always pick the median, then we will be able to always get the best case. But if we use random, right, it's not 100% that it's only when we are very very lucky then we will pick the median. So our first option is to pick the median. But if you are not able to develop an algorithm to pick the median, then you can use randomize because probably when randomized, usually it will run on average case.
Yeah, so this is mean by my answer. So we can like avoid many cases. I mean, instead of choosing the leftmost, maybe they're sorted. So maybe the smallest is on the left. So by randomly picking, we can avoid that possibility. Yeah, but picking median is the best answer for this question.
But right now, picking the leftmost or the rightmost, right, we wouldn't know because it might even the rightmost or the leftmost might be the median of the entire element.
Yeah, because random we do not know random what is the next step for the random.
Yeah, for random we have no idea or what are they going to pick.
Okay, thank you, Doctor. Understand.
Okay. So if we let me share. I just want to extend my the explanation. Okay. So right now for quicksort, right? Hold on, yeah. So let's say we are able to always pick the median. Okay, so let's say you already develop instead of using the random to select the pivot, you develop your own algorithm to always select the median. So when you always select the median, right, means is always divided by 2. Okay, n is always divided by 2 and it's like even. The left subarray and the right subarray is even 3. So when it is even 3, okay, I try to use my pen. Currently, every time I use my pen, there's some it will hang. So just now I was saying, right, let's say we have this array, we have 80, 60, and then 70, 10, 20, 30, 3, 90, 40. 1, 2, 3, 4, 5, 6, 7, 8. That's another number. And we have 50 here. Okay, so we want to sort this using the quick sort. Okay, let's say we take the random number. We use this like the random function, this random like that. Okay, so when you use this algorithm, right, I think it's offered by the Python, then it can choose any. So it's like depending on our luck. Okay, like the one in our lecture, I always put choose the leftmost. Okay, so let's say we do not want to use this random. Okay, we want to calculate the median. So somehow you need to develop one algorithm to calculate the median for this. So okay, so let's say we are able to pick the median. So the median here is 50, right? So then after that we will run the quick sort. We will run the quick sort until J ends. Okay, when we run the quick sort until J ends, right, it will look oh, this one happened to be, wait I changed a little bit. Okay, so it will look something like this: 40, 30, 20, 50, 80, 60, 70, 90. So right, this is because this is our pivot. So this one is already at the right place. Can you see that this is our left sub array and this is our right sub array? So it is like how come I have less number? Oh, sorry, over here is 10. Okay, so you see it's like even array. So when we get the even array, right, when we draw the tree, right, it will be balanced tree. So when it's balanced tree, right, then we will get n log n. It's like the best case. Alright, and then after that, you can see here that it's still unsorted. Let's because we are talking about the quick sort. Let's say we want to do the randomized select, right? We will that's why we will compare the k with the I. Okay, so we will compare. Okay, so this is our k, this is I. Is it same or not? If it's not same, then we will see whether the I is bigger than k or not. If I is bigger than the k, then we can do the searching over here. That one because for randomized select. And then if it's I is smaller than k, then we will do on the left side. But if we are talking about just the quick sort, right, we have to do both sides. Okay, that's the difference between the quick sort and the randomized select. So over here, you can see that we still need to select the median. Okay, then when we select the median, then you use your own algorithm, don't use randomized, then you can pick your median. So this one got no choice because it's even. If even number of input, right, we need to take the divided by 2, and then we need to take the floor or the ceiling. That's why in our slide, I did mention about this. Okay, so if it's odd, then is we can have the n plus 1 divided by 2. If is even, right, then we can have two possible median. We have the lower median or upper median. Okay, so so we can choose either one. So that's the same case as these two. We have the ceiling and the floor for the median. So let's say we want to take the high, the ceiling medium, right? Then the 30 should be picked. All right. and then they will do the sorting and so on. Okay, so if we keep on taking the median, right, we can always divide this by 2. But if we pick the biggest among all, right, then we cannot divide it, because after we do the quick sort, right, this 40 will be over here, right? So we have to do all this together. But if we do 30, right, 10 and 20 will be here, 40 will be here. So it save more time. So that is the concept of quick sort on and how we can get the order of n log n. Okay, I noticed that maybe the question here, right, is kind of confusing, because they said that in time of worst case, because quick sort, the worst case is n square, right?
I think the question say how to like save the worst case conditions.
Oh.
Like how to survive from the worst case.
How to survive in the worst case. Oh, okay. All right. So I agree with this answer, choosing the median as the pivot. Okay. So this got to do really with the randomized select. So just now Islan was requesting me to explain about the randomized select. Okay, for the randomized select, I just want to give you clue for question number 4, because while I'm explaining the randomized select, then maybe you can get some idea about question number 4. Okay, so before I explain about the randomized select, I feel that in my opinion, I have teaching this course for quite a while, and all students give me a lot of interesting ideas that I totally agree, but I just want to relate this with the randomized select, since this is what we learn. Okay, so the question is, this professor named Ole is consulting an oil company which is planning a large pipeline running to east and west through the oil field and end well. So this is the well. Okay, so I just tell you this one. These are the wells. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 wells, and then the company wants to connect a spur pipeline from each well directly to the main pipeline along the shortest route, either north or south. So given the X and Y coordinates of the well, how should the professor pick the optimal location of the main pipeline, which should be, okay. So this is called spur pipeline. Okay. This is called spur pipeline. So they want to pick the optimal location for the main pipeline. So this is the main pipeline, the one highlighted in red. So currently they want to know, okay, where to put this pipeline. Do you think is here will have the most optimum? Means, right, if let's say they use here, right, means they can save cost in building this spur pipeline or not. Let's say they okay, or is it they go all the way here? So roughly, right, how to what is the best way to decide this? What do you think? So your job is to minimize the total length of spur pipeline by determining the main pipeline where the main pipeline should be located. Okay, so we You wouldn't know this one or this one. Where is it? Okay, so to be exact, we can specify the coordinate. So right now, right, which axis should we consider the most, the y or the x-axis?
Y-axis.
Yeah, okay. So because the x is not really related, okay, so we should just look at the y. So right now, I can see that there are two perspectives of mine. Some of you may think that, okay, we need to measure the coordinate of y to the exact, and some of you may just think that, okay, we have how many n here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9. So let's say we want to select the median. So 9, it will be the median will be 5. So so maybe it, so one over, so it will be somewhere in between here. Okay, so whatever it is, right, we can apply the, wait, let me, you can think of how to okay, which would be the one that minimize the total length of spur? How to show and determine the optimal location in linear time? So we need to use the algorithm that can be completed in ON. Okay, alright. So having that in mind, so maybe you can think while I re-explain about the randomized select. So randomized select, because it used the concept of order statistics, so we need to select the I element. So let's say we want to pick the median, right? So the I element should be the I element, this I, right, it means the index, okay, not the value of the element. So when we want that refer back to here, let's say we want to take the median, right, then the I element we can use this formula to get the median. And if we want to select the minimum, then the I will be 1. If maximum, the I will be n. Okay, so currently I'm just explaining the I element can be 1 or can be n or can also be median if we want to pick the median. But let's say they don't really, it can also be in between. So they can say, for example, the seventh element in the array. Okay, you can choose depending on the problem. So here, after randomized partition is executed at line, after randomized partition is executed at line 3, okay, so this is line 3. The array PR is partitioned into sub-array. Okay, this PR, so at first we have the full set, okay, and then we will check whether the P is equivalent to R or not. If P equivalent to R, right, means there's only one element inside the array. Okay, like here, if P equivalent to R, there's only one element because P and R is the same index. So P is the first index of the array and R is the largest index of the array. Okay, so we can just return, we can just select whatever that it is, or you can also say that, okay, the I element is this, or is not there. Maybe they want to find the 7th element, so we only have one element. So this return, right, you need to try to return whatever that is meaningful. So back to here, then if it's not right, means it's bigger than 1, we can do this randomized partition. This randomized partition, they will do, this is where they will do the quick sort. So this is where they will do the quick sort. So line, okay, because at line 3 they will do the quick sort, right? The array PR is partitioned into 2 sub-array, the P Q minus 1 and the Q plus R as the pivot element. Okay, so this is what happened. So for this is the example of the array, and we need to select the 7 smallest. So right now they pick the pivot. Okay, let's try to do line by line using this example. So is P equivalent to R? Is P equivalent to R? No. Okay. Then we can proceed to this randomized partition. So this randomized partition is where they do the quick sort, exactly like the quick sort. So when they run the quick sort here, right, then we get this answer. Okay, but we are not doing the entire quick sort. We are just doing like the partial quick sort here. So you can see that now the pivot is already at the right place, and the leftmost is smaller than 6 and the rightmost is bigger than 6. Okay, so if quick sort, right, then they will divide it. But for the random select, they will do the checking. They will get the value of K. Okay, so in this case, K is Q minus P plus 1. So in here, right, Q is equivalent to 3, right? 0, 1, 2, 3. P is equivalent to 0. This is 0. P is the smallest index. Okay, and plus 1. So when is 3 minus 0 plus 1, then we will get 4. Okay, so this K, right, what is K? It means there are 4 elements in the array. 1, 2, 3, 4. Okay, so then they will do the checking if I equivalents to K or not. So what is our I now? What are we trying to find? Our I is 7. Okay, so I is 7, K is 4. So it's not equivalence, right? If it is equivalence, means we already find our I. So this is our I. If our I is K, right, then we have found it already. But right now, it is not. Okay, then after that, we will do the checking. Now, is I smaller than K? Is 7 smaller than 4?
No.
No. Okay. So if 7 is no, right, then we will do the else. Okay, we will do the else, and this is the recursive coil and different value that we will put in. Therefore, we will give array. Okay, array Q plus 1. So this is Q, right? Q was our pivot plus 1. And then R, and then I minus K. Okay, so over here 3. So over here we will call back this random select. Okay, so that is how the algorithm works. But what it means, right? Right now we are trying to find the 7th smallest, the 7 smallest in this array. Okay, if we use the binary search tree, right, our condition is we have to sort the entire array, then only we will do the searching, right? But this randomized select, they're trying to be cleverer. So instead of do the entire sorting, right, they will use the quick sort to see. So right now, since I is the 7th smallest, means the I is somewhere here. See, so they will do the sorting to search for the I smallest at the right subarray. And if you notice here, they skip some of the work. It's still not sorted and they don't care. Okay, because it is not relevant anymore to search here. When this is the beauty of random select and how they are able to reduce the time complexity. Therefore, okay, so for I is 7, right? The 7th smallest is, okay, you see here, this is the first smallest, second smallest, third smallest, fourth smallest, fifth smallest, sixth smallest, and the 7th smallest. So they are actually looking for 11, and you see 11 is over here. Okay, so once they have completed the first from line 1 to 9, right, and then they will do the recursive call to search for this. Okay, so you will need to continue doing the same thing, and lastly it will stop when the I is equivalent to K. Then at that time this thing is already sorted, so we will know what is the value. Okay, so that is randomized select. So once you are able to understand this, right, let me just read through my note. So this one, after randomized partition executed in line 3, the array APR is partitioned in 2 subarray. Okay, the left and the right. Okay, you see is Q minus 1 and Q plus 1. The Q is already at the right place, and they will just check is the Q the thing that we want to search or not. If no, then okay, we can skip. Okay, and then at line 4, it computes the number of elements in the subarray. Line 5, check whether the AQ is the I smallest element. If it is, then AQ is returned. Otherwise, the algorithm determines in which 2 subarray the I smallest element is located. Okay, then line 7, it will check if I is smaller than K, then the desired element lies on the low side of the partition. Okay, the left side of the partition, and it is recursively select from the subarray in line number 8. So it will execute line 8. But if I is bigger than K, then the desired elements is on the high side of the partition. It means on the right side. Since we already know K value are the smaller than the I element, okay, of P array P to R, the element P to Q, the desired element is I minus K smallest element of Q plus 1 to R, which is found recursively in line 9. So this is exactly how I explain in here. So in line 9, we know that it is somewhere to be searched here. Okay, so this one is just to understand the variable that I have explained earlier. So does this is it okay, Islan?
So the for randomized select until we found the exact effect, there will always be that have part of fixed.
Sorry. Come again.
So for randomized select,
Mhm.
until we actually select the index element, to get the element, we always have to do quick sort for that part of the array.
Yes.
Okay. I think I understand. Thank you, Doctor.
They will do this until I equivalents to K. If not, means it's not found yet, then they will keep on doing the quick sort. So they will sort only the necessary partition. Okay, they do the exclusion. That is the how they win in terms of time complexity compared to the binary search. Okay, because binary search need to search everything. Needs to sort everything first. This one they just do sort selectively. Doctor, can the main pipeline be tilt? No. In this rule, they cannot tilt. Okay, so for our last question, who would like to share? After chit-chatting with a few groups, right, some students feel that they don't want to answer because they feel that their answer might be wrong. It's okay, it's okay to be wrong. Okay, as long as you give your idea, then I can and then sometimes, right, even the slight idea, right, can trigger somebody else to have a different idea. So it should be in the form of discussion. So any interesting thing that you want to share, just shoot. Okay, gonna unshare. Who would like to try?
Okay, I think it can relate to linear regressions concept.
Linear.
AI things we learn the ML, then it seems like to have strict line passing through the point, right?
Okay.
Then I assume that we can calculate the mean square error between the point with the line. Then we total it, then we just select the minimum mean square error. That means the line is the best line.
Oh yeah, okay.
I haven't do that because I'm not sure the concept is correct or not. I just tell the idea. Yeah.
Possible. Your meeting, do you have any idea to share? Yes. Okay, who would like to present? I see that there are somebody paste answer. Can you explain?
Doctor, actually, that one I found on Google and I pasted.
Okay. Do you manage to understand it or explain a little bit about this?
Actually, I'm not so sure also, but
Hmm.
I can try out.
Okay, since you are not so sure, we try Kishore. Any idea about this?
Doctor, even I saw the answer on Google the same way. But from my understanding, I think we can choose the median because if we move the pipeline to the north, the length of south spur will increase. When we move the pipeline to the south, the length of north spur will increase. So I think we can choose the median. So the length of the north spur and the south spur will be like almost same. So that would be the ideal location of the pipeline, I guess.
Okay. Islan, you want to try? You want to give your opinion?
I don't quite understand it that much to give my opinion.
Okay, alright. Anybody?
I think I understand in front a bit. So basically, you find the total distance, right? Then you find the median, the best line for the x.
Okay, when we say the total length, right? Is it this total length?
Yes. Then
So
you
means
add up together.
we add up this. Is it?
Yeah. Then we find the average, the median.
Yeah. Okay. So if we have this, right? So we have 9. N, our n is equivalent to 9. So do you think we can replace the elements to the length so that we can use the random select?
Maybe we can give some few parameters of the possible solution, like I think if the gradient is constant, that means the y-intercept keeping changing only. So we maybe give a range of from the minimum to, I think, yeah, from minimum to minimum. That means the negative of the upper side of the line and the minimum of the lower side of the line. Then we can like making the change of the y-intercept. Then we can choose the shortest or the median of the length, the total length.
Yeah, almost there. So is it okay if okay, how to apply a random select in here? Because random select we can select the minimum and maximum, right? And then we can also select the median. Okay. So let's say here our n is equivalent to 9. So is it possible if we do our array the length of here? Okay, ignore this. Maybe this one is 12. So we can do here 12. So here is 11. Is it possible to do that until, and then try to find the how to apply because right now our median it will be 9 plus 9 plus 1 divided by 2, right? Then that will be our median, right? Equals to 5. So we need to find the fifth smallest, right? Is it?
Yeah, I think so.
Okay. So how to proceed this? How to use randomized select? Because this is the question where we try to apply our knowledge to solve real life problem. So can you think of how? Okay, so fifth, we need to find the fifth smallest. Okay.
We can actually, we take the distance, right? Then we map it to the x and y coordinate. So basically, we will recalculate, we will sort it out. So like x6, y6 is the smallest distance. Then second is x3, y3, etc. Then we will find the median there.
That's the easiest way, right?
Yeah.
Yeah, like your friend said just now. It would be good if you can think of how we can use randomized select in here. Okay, but as for now, we can I think already 2 students said the same thing. So we can try to. Sorry, this one is already different tutorial. This was like okay, I don't know. This is one of the solution that I can think of, but this one is not using the randomized select. Basically, I just assume the value here, and then I'll take the median. So the line should be somewhere at somewhere here, so that you know it will we have the optimal length of the spur pipeline. Okay, so I hope that you can try to if you have any, then you can suggest. Okay.
Doctor, you mean you suggest new solutions or?
Yeah, suggest new solution, maybe to use some algorithm. Okay, but because this one is done manually without considering using the random select. Okay.
Yeah, maybe the new solution that I suggested is using the cost function, the mean square error function. That means we sum all the means the square error between the line. Then we can if the mean square error become minimum, that means that better choice for us for the y-intercept that we choose.
Okay. Do you want to display something or share something to
Okay,
illustrate? Okay.
Because it's quite similar to the case that we learn in machine learning now. So maybe can share with some students of different departments.
Okay.
Doctor, can you see my screen?
Yeah.
Yeah, this one is actually just a formula for cost functions. That means if the cost function that we calculate for the point, right, is in minimum, that means it's approaching zero, means good solutions. That means since the m is a constant, right, that means we can only modify the y-intercept here. So as the y-intercept modified, that means the line will be keep changing, right? So just calculate the distance between the point here and the point here, and then we square it. Then yeah, just suggest some of the range of the y-intercept lah. So and then we will get like a series of the value for the j theta. So like maybe it's 1, 2, 3, 5, like 1, 7. So when we get a series of the minimum, the j theta value, right, when we test a several value for the y-intercept, maybe the y-intercept is here. Yeah, maybe we test the y-intercept here. So, and then test until a value, the j theta will be different if we test different things. Then we just use the random select algorithm to select the minimum j theta. So minimum j theta maybe reflects some the y-intercept. That means we can accept the y-intercept, and then the solution is found. Yeah. Did you understand, doctor?
Yeah, I understand. Okay, so means using this we keep on having to test, right?
Yeah, just test the value.
Get several j theta.
Yeah.
Then use the random select to select maybe the minimum, because minimum it means that that is the most optimum cost, is it?
Yes.
Okay, that's good.
Thank you, doctor.
Thank you, Moy. All right, so with that we can end our tutorial session today. Okay.
Doctor, I have a question.
Yeah.
Our midterm will cover what until which chapter?
Our midterm will cover divide and conquer, and probability it will cover lecture 5 and lecture 6. Divide and conquer, and this week probabilistic analysis and randomize.
Okay, thank you, Doctor.
Yes, Kishore, the midterm will be on week 9, and I will make announcement. Is MCQ, 10 question for divide and conquer, and 10 question for probabilistic analysis and randomized algorithm. Okay, so it's 20%. Welcome. So thank you all.